more importantly, it has all the features of what we talked about yesterday inside this simple question. I say simple, but this is very much what they could put on the test. There's no surprises here. I'd say the modern test is probably a little harder than this, but this is a physical pendulum question. And it's got all the features of it. Take a look at it tonight if you haven't done it, get it submitted. I've answered questions about it in the other classes. I've posted those videos. Try not to watch it. I'm going to be posting FRQs very frequently now. And my intention is that, and I know you've already got other homework, you've got stuff you're working on, you're really busy. Get over yourselves. In 4 weeks, it's over. Right? 4 weeks. AP exam and done. So it's going to be a hard 4 weeks for some of you. You'll survive. Other kids just like you have. But when you see one of these posted, I'm expecting you set your timer for 15 minutes. Start the question. Stop after 15. Does that make sense? It is 15 minutes of work. Do it first. Don't hold this one for midnight. You know that this is going to be the one that's going to be harder than your other homework. Do it first. Especially if it's something nebulous like you have to study for a test. That can take forever. This will take 15 minutes. Okay, set the timer. Now, since many of you haven't tried it, please do. I don't want to talk about it any more than that. More questions. I've done, I think, 5 so far on the homework. If you have one you're interested in, I have started or at least gone part of the way through many of them. So if there's one that you specifically want me to take a look at, I would be happy to speak to you about it. I think I've talked about number 18, 21, 37, 52, 57, and 75, I think is the ones I've had a chance to speak to, but I will speak to whatever ones you want. Yes, ma'am. 11, sure. What else? We have time for a couple. Yep. 53. What?
21, part C.
Okay. Well, then don't repeat it. All right. That's probably as much as we'll get in the time before the bell rings. So let's start. Number 11. An object in simple harmonic motion has an amplitude of 4 centimeters and a frequency of 4 hertz. It passes through the equilibrium point moving to the, at t equals 0, it passes through the equilibrium point moving to the right. Write the function x of t that describes the object's motion. All right, so they're telling me at t equals 0, it's at equilibrium. So we're probably going to use sine for this and not cosine. Our cosine is based on t equals 0 being at maximum displacement. Here they're telling us that it's at equilibrium at time 0. You could use cosine, but you'll need a 90-degree phase shift if you want to do it that way. So I'm going to use sine. So x as a function of t is going to be x naught sine something times t. They gave me that, let's see, I have the amplitude as 4 centimeters, so this, put in 4 centimeters. And my frequency is 4 hertz, so frequency equals, let's see, omega divided by 2 pi. And they tell me that frequency is 4, so omega is 2 pi times 4. So that means that this area is 8 pi. There you go. That's my function at t equals 0. Any question about, yes? Because it says that it's at equilibrium at time 0. Okay. 21, part C. All right. I'm trying to do these all in a similar way, and this one will be no different. Do we believe that the mass on the spring is going to have simple harmonic motion? So it says that I put a 500-gram physics book on a spring, which causes it to stretch 20 centimeters. What is the spring constant? I need that to do part C. So we'll just do that real quick. mg equals kx. If I hang something on a spring and it stretches at 20 centimeters, this is the best way to figure it out. So that's going to be 0.5 times 10, your book uses 9.8 probably, K times 0.2. This will give me the spring constant in newtons per meter. And let's see, that's 5 over 0.2 is what K equals. So it looks like K is 25 newtons per meter. It says that they pull it down an additional 10 centimeters and release it. So X naught is 0.1 meters. They would like the maximum speed of the system is what question C asks. V max is X naught times omega. I would be very concerned about trying to use conservation of energy here. You could, but be careful. Potential energy is changing all the time here too. You'll need to include potential energy in this calculation to get the answer right. So I would just use this, because this is guaranteed to get the answer right. So X naught is 0.1, and omega is going to be the square root of K over M, which we have as 25 divided by 0.5. Is that good for 21C? All right, so 25. A 200-gram ball is tied to a string. It is pulled to an angle of 8 degrees and released to swing as a pendulum. A student with a stopwatch finds that 10 oscillations take 12 seconds. How long is the string? There's some extraneous information here. The 8 degrees tells me that I can treat this like a simple pendulum, so I will. And the fact that I'm treating it as a simple pendulum means that I can use this formula and the fact that we have information leading us to the period. The period appears to be 1.2 seconds, 12 divided by 10. 10 oscillations in 12 seconds. So 1.2 seconds equals 2 pi times the square root of L over 9.8. And I'm going to leave it there. I think that's sufficient enough for you guys. I don't know who asked about 25. I'm just telling you how I think it is. Is that okay? So I'm going to move on to number 53. All right, 53. A 1 kilogram block is attached to a horizontal spring with a spring constant 2,500 newtons per meter. The block is at rest on the frictionless surface. A 10 kilogram bullet is fired into the block in the face opposite the spring and sticks. What is the bullet's speed if the subsequent oscillations have an amplitude of 10 centimeters? Bullet, block, spring before the collision, bullet, block, spring right after the collision, and bullet, block, spring when the system has come to rest. That's how I see this problem. I'm not seeing oscillations or anything. I'm seeing 1/2 k x squared here. And I'm saying that that's equal to 1/2 m v squared here. And I'm saying that I have mv plus 0 equals m plus m times v here. I see a collision where the two objects stick together. This is the initial velocity here. This is the final velocity when they stick together. That's what you're going to use here. And you already have this information. You're going to work this problem starting step 1 to step 2 to step 3. Does that work for you guys? All right.